Hello, I'm Nobby. Welcome to the workshop. Before I start showing you my next project, I wanted to show you another sticker that I've received from my sticker board. I was contacted by Myford Boy, who said he would like to send me one of his stickers for my board. Obviously we've done an exchange. I've sent him my sticker as well for his workshop. I guess most people are going to be very familiar with the Myford Boy channel, because his channel's been around a very long time and he has a big following to his channel. I've been watching the videos that he's put up for a long time now. He's a sort of a model engine maker. He makes all sorts of engines and sort of tiny model trains as well. He has a very nice workshop, and obviously he has a Myford lathe, but I think the lathe is possibly an ML10, and a nice milling machine, quite an old one. I think the milling machine is a Ragland milling machine, but I'm not absolutely sure. But his channel is very varied indeed. He's quite an expert at 3D printing and showed many 3D printers, some of which he's shown tests that he's made on them, upgrades and modifications to them as well. He also has a laser cutting machine and a laser engraver. And along with a sticker, he sent me a little card. You can see that clearly, which I believe it is laser cut, and I'm pretty sure that he laser cut this little card himself. Very nice thing to have. Something that I guess he's very well known for is metal casting. Metal castings in aluminium and zinc mix, and he's produced quite a lot of engines which he sells the castings and plans. You can order these up from him through his email address. And a few years back, my wife bought me the Myford Boy engine kit. I think I built this in I think it was about 4 or so years ago. I think I built that, and it basically was only the second engine that I built, and so far the only one I've actually built from a kit. He supplies the castings. There's 2 castings, the body and the flywheel. The flywheel is obviously something that I couldn't make anyway. All the other parts, there's lots of parts, a lot of brass parts and some steel parts, which you supply the materials for yourself and machine up. It was a fantastic project to work on. I really enjoyed doing it, and the engine turned out very nicely, and pleased to say that it started first time as well. So I was very pleased with that. So if you're not familiar with the Myford Boy channel, do give it a look. I'll put a link in the description of my video here. So give Myford Boy a look. Obviously, if you like what he's doing, I'm sure you're going to subscribe to his channel anyway. So Myford Boy, I'm going to put your sticker here. That will sort of actually fill up the first panel on here. So I've got to be very, I think I'll do it that side. See if I can get this one on nice and straight. I've got Matty's one a bit cockeyed, but I have managed to peel it off and put it on a little bit straighter this time. So hopefully I've got that straight, and we'll peel it off. So there we are, Myford Boy. There's your sticker in place. Looking very nice now, the board. So anyway, without further ado, we'll now sort of get on to the first part of my new project, which I hope you'll stick around to watch. So thanks very much indeed, and thanks very much for joining me. Thank you. Hello, I'm Nobby Clark, welcome to my workshop. This is the start of a new project, and what I need to do is this piece of steel. This is 2 inches long, so I need to drill a series of holes through this, a couple in the centre and some holes very close to the edge of the material as well. I've done a similar project to this before, and normally I would use in the vise these 3-inch parallels. This is a 3-inch vise. But you see, the problem is that if I rest this metal on the parallels here, you can see the parallels are just over half the width of the material. So drilling the holes on the edge here, they will drill into the parallels and damage the parallels. So what I've done in the past is used sacrificial aluminium parallels that I made. You can see it's got holes in this piece particular on both sides. The other parallels I was using were actually completely destroyed, so rather than ruin these as well, what I've done is I've made a couple of very thin parallels. I think these parallels are sort of about just an eighth or just over an eighth of an inch in width. These are 33 thousandths thick, so both of these together would actually be fine, but obviously there's only going to be one on each side, so there shouldn't be any danger of me damaging these at all. I mean, as I've made these myself, they could be classed as sacrificial. When I made them, I aim to make them sort of round about 3/4 of an inch in width, which would fit quite nicely below the top of the vise jaws and hold that piece of material easily in place. I mean, they ended up at 798 thousandths, which is fine. I could have machined them down to my target measurement, but quite frankly that just didn't matter at all. So I can place these in the jaws here, and what I'm using is my spring device to hold the parallels apart, just to keep them in place. You know, these are very thin parallels, so they would easily move away from the face of the jaws themselves. So put those in there. Now what I need to do is drop this piece of material in, but aim to have it overhanging at one end so that I can use my edge finder for the first a couple of holes to be in the dead centre. So just drop that in there, knock that down, and then lock that nice and tightly in place. And now I can edge find to find my sort of half measurement here for the centre. So I'll bring my edge finder down, put that in the centre. This is a very nice edge finder because it's an electronic one. It gives you an audible signal and a light as you touch the edge here. So sort of, you know, no mistaking that you've got it exactly in position. So listen out for the bleep. And zero up the Y. Just bring that in again to double check. Yeah, that's fine. So bring that off the edge and then move to the other side. the way and double check that. Also, you can check your position here as often as you like, actually. That's it. I'll do it again. Yeah, that's fine. So bring that up and feel the Y, go for the half measurement and draw that across the 0. It's gone past it. I overshot slightly. It's very easy to do. Here we are. That's. There we are. So now we're in the dead centre of the part. So I can lock off the wire movement. And what I need to do now is find the edge here so that I can measure across to my first hole position. So bring the thing down. And this type of edge finder, you have got to be very, very careful with it, because unlike the if you like the mechanical ones, the bottom of this and the ball don't move at all. It's purely finding the centre and giving you the audible and visual indication. If you ran this over too far, you could obviously dislodge and damage the ball itself. So a lot of care is required in using this. X and bring that out, come in again, that's it, that's fine, raise that up. Now what I've got to do is move the table along this way to half the measurement of the ball itself. I mean, it says that this ball is 10 millimeters, but in fact it is slightly smaller, and when I'm going by an imperial measurement, so I need to draw this across 1965. So we're nearly there. There we are. So now I'm directly over this edge here, so all my measurements now can be measured out from that position to the hole positions that I need in here. I've removed the edge finder and put my drill chuck in, so, and a centre drill in here as well. So I've just got to now measure across to the first hole position. Just looking at my drawing, which is 3/4 of an inch. So bring that across. That's it. That's ready for the first hole. Some casting oil on there. change over to the drill, just check the drill size. That's right, so I'm drilling a 5mm hole. Cutting oil. This is the first hole. Now from here, the second hole is a further 1/2 inch along. I'll move across to there. That's it. Centre drill in. Sorry if I'm blocking the camera position a bit. There we go. That one back in with the 5mm drill. That's it. I'm sure that you probably guess what I'm making here. What I've got to do next is set this up for an end mill to cut a slot between these two holes. Well, I guess it's pretty obvious what I'm making. I'm making another toe clamp, but bear with me because this one actually is a bit of an experiment. It's going to be a completely different design of toe clamp to all the previous ones I made for my fixture plate. So I've got to machine the slot in here, but then I've got to drill some holes nearer to the edge at each end of the plate itself. I mean, I'll show a bit of the milling out of the slot in here, you know, just in case you're interested in seeing that, but probably I'll bring you back for a bit more of drilling when I'm drilling these holes at the end. I'm hoping it doesn't become evident straight away what I'm doing, because this is for me sort of a bit of a prototype, if you like, in terms of a different idea I've got in making a toe clamp. But bear with me and we'll see how we get on. of the cutters is broken through now, so what I need to do now is bring the cutter end to end, just to sort of clean up into the where I drilled the 5mm holes there. There we are, so that's that part done, and it's the end mill here is a 6mm end mill, because all the hardware on my fixture plate is 6mm, so that slot is now complete. Obviously I've got to sort of deburr all round it as well, and then reset everything up to drill the other holes. I'll bring you back for that part. Now what I've got to do now is drill 4 holes, 2 at each end, in position here and here, and the same at that end. As I'm drilling the holes, it's quite a it's a symmetrical pattern, so I hope you don't think I'm cheating here, but what I've done, I've marked out the position for the first hole, so I've got a scribe line in both directions here, and I've used this little pointer here to centre up for the first hole, so that's centred up nicely, and I've locked the X and Y on the bed of the mill. So what I can do basically is I can drill a hole here and flip the material over and do the same at the other end. You see I'm using my vice stop here so that I can get the metal in exactly the same position every time. I'm hoping this is going to work out okay. It saves having to line up for every hole individually. I mean, I could use the digital readout to do that, but I thought this would be, you know, perhaps the easiest and quickest way of actually doing this. So I'll remove the pointer and I'll put in a centre drill, and I'm drilling a 2.5mm clearance hole through these. These are not being tapped, it's purely a clearance hole. So I've replaced the pointer with a centre drill here, and I can now drill the first hole. Put some cutting oil in there. this is the test now to see whether my theory works or not. It looks as though it's worked. Looks okay. So what I've got to do now is reverse that in the chuck here and do the same this end. Well, I would say that's been a success. The holes do look as though they've lined up perfectly. I know there's lots of people that say, you know, I shouldn't do it this way, but you know, why not try other methods? And that's the whole purpose really of having a vice stop as well, you know, so that you can get a piece of material in exactly the same spot every time. So I'm quite happy with that. Obviously I've got to just deburr all of these, and I've also got to put countersinks in all of these holes as well. And there's another operation on this piece as well, which I'll show you. I'm not sure if I've ever shown this vice stop before or not. It's made up out of literally all sorts of bits and pieces. this was one of a number of T-nuts that I made for the milling machine. Made quite a few of these. I also made some with 8mm holes. I think it's just 6mm, and it's just literally simple little bolt that goes through there, and just a block of aluminium. I actually punched the date on, well, the year I made it. I made it in 2020, and these parts were, if I remember rightly, were just bits of an old indicator stand that I had, and just an ordinary piece of brass rod. It works quite nicely. You see all sorts of wonderful designs for vice stops on YouTube. I mean, this vice does have holes, screw thread holes here and at the back here. One use of these is you can move the hard faces of the jaws to the back if you want to clamp in very large pieces of material in place, which I have done before. And I know a lot of people make a stop by putting a plate at the back here with an arm across here, and then another arm that goes into the vice jaws to hold material in position. I did make one like that for for use with a different vice that I had. I had a toolmaker's vice that I used to use on the milling machine, and that had a hole in the side here. I think I've still got that vice stop somewhere, but this was sort of made up sort of very quickly one afternoon for a job I was doing, and this works fine. You know, no need to make the vice stop a really complicated thing. Just put the little T-nut on the end there, so that works quite nicely. And obviously all these parts I didn't make all these bits. They were just bits that were already there, so I thought, well, might as well make use of them. But I thought I'd just show you that, because I'm not sure I've ever shown this before as a shop made tool or not. I thought I'd quickly show you. This is, I mentioned the original vice stop that I made for the toolmaker's vice, and again it was just a very simple block of aluminium, and I literally used 2 bolts. The bolts that had were obviously very long bolts. Obviously there was threads running sort of here and onwards, and I used these bolts because on that particular vice I assumed the thread, the threaded hole on the end here, I assumed that was a metric thread, because it's a modern vice that I bought, brand new, but it turned out that it was actually an imperial thread. Didn't realise that until I actually worked out what the thread was. So I just sort of chopped off the other bolt here, and then just sort of re-threaded the end of it, so that part would screw into the side of the vice there. Obviously that vice is a completely different size to this one, and then you've got this arm that you can run in to use as the stop, just with a couple of simple cap head screws on the top that you can lock in place, and that works fine. I mean, it doesn't have to be a very complicated thing, as long as it can all be locked up nice and tightly. It's going to work fine. So I thought I would just show you that. While I was showing the other one, I was looking around the workshop, and I've got a tool rack behind the lathe next to the milling machine over there, and I actually spotted this there. I've obviously sort of kept that in because I could still use that other vise on the milling machine as well, and I have done on occasion. I'm actually going to call this end of part one, because this is already quite a long video now, so I thought I'd split this into to two halves rather than make it a really long video. So hopefully if you've seen this and like it, you'll look out for part two. Bye bye.